Good morning, children. So, we were doing the chapter quadratic equations, and before the first term, we were doing questions related to forming quadratic equations. Okay, well, if roots are given to you, then how you're going to form the quadratic equation. Now, let us see the next question. So, here the next question is this. This had come in 2019. Okay, it was given for 6 marks. So firstly, let us read the question. So here question says, find the value of p such that the difference of the roots of the equation x squared minus px plus 10 equal to 0 is 3. So this is the quadratic equation and the difference between the roots is 3. Next they are saying that if the roots of the quadratic equation are alpha and beta, find the quadratic equation whose roots are alpha plus beta whole square and alpha square beta minus alpha beta square. So here x square minus px plus 10 is equal to 0. This is given to you, and they are saying that alpha and beta are the roots of this equation, and they are saying that difference between the roots is 3. Let's say I assume that alpha is bigger than beta, then according to question alpha minus beta has to be equal to 3. Okay, so and what we are supposed to do is at the end we are supposed to find we need to form a quadratic equation whose roots are going to be this 2. Okay, so in order to form the quadratic equation we have to find the value for alpha and beta. So in order to find the value for alpha and beta, we have to use this information. Okay, so let us proceed. Okay, solution. Given alpha and beta are the roots of x square minus px plus 10 is equal to 0. Suppose alpha is bigger than beta, then alpha minus beta will be equal to 3. Put this as equation 1. Okay, now you know that sum of the roots is given by, like if your quadratic equation is this, ax square plus bx plus c is equal to 0, and let's say alpha and beta are the roots for this quadratic equation, then sum of the roots is given as minus b upon a, and product of the roots is given by c by a. Okay, we know this much. So here alpha plus beta will be what? By this formula, minus b upon a. So it will be minus, and here you can see in place of b what you have, minus p, so you will put minus p, and in place of a what you have, 1, so you put, so you are getting alpha plus beta is equal to p. Put this as equation 2. Okay, now you have got simultaneous equation, okay, in alpha and beta. So you can solve equation 1 and 2. Okay, you can solve equation 1 and 2 to get the value for alpha and beta. So now what we will do is adding equation 1 and 2. So when you add equation 1 and 2, this minus alpha and here plus alpha will get cancelled. So you are getting 2 alpha is equal to 3 plus p. So you're getting alpha is equal to 3 plus p upon 2. Done. And in order to find the value for beta, what we'll do this. Next, equation 2 minus equation 1. So equation 2 minus equation 1. So here what will happen, like here you can see this is alpha plus beta is equal to p. This is equation 2 and equation 1 will be this. Okay, so you're subtracting actually. So this will become minus, this will become plus, okay, and this will become minus. So you get 2 beta is equal to p minus 3. So beta will be equal to p minus 3 by this. Okay, so this one was done in rough. Okay, straight I can write now that we will get 2 beta is equal to p minus 3. So beta will be p minus 3 by 2. Okay, so you got alpha and beta in terms of p, but we are looking for the value of p. Okay, and we don't want alpha and beta in terms of p. Okay, so now next is, we know the product of roots, that is alpha and beta, will be what? C upon a. But here you see that your C is plus 10, okay, and a is 1. So alpha into beta you will get 10. Done. Put this as equation 3. Now you use the value of alpha and beta in equation 3. Okay, so now using the values of alpha and beta in 3, so what we'll get? We'll get 3 plus p, or you can write like this, p plus 3 upon 2. This is your alpha, and your beta is p minus 3 upon 2 equal to 10. Now you can see the numerator here, you have p plus 3 into p minus 3. So it's like a plus b into a minus p. So you will get p square minus 3 square, that is 9, and down you are getting 4 and here 10. Now next you can write p square minus 9 is equal to 40. Okay, then you get p square is equal to 49. So p will be plus minus under root 49 equal to plus minus 7. Okay, so this implies p is equal to plus minus 7. Then your alpha will be equal to p plus 3 upon 2, and your beta will be equal to p minus 3 by 2. So alpha equal to plus minus 7 plus 3 upon 2, and beta plus minus 7 minus 3 upon 2. So okay, one second. Since we have got two values for p, no? So what we'll do, once we'll take plus 7 and once we'll take minus 7. Okay, so for p equal to 7, okay, your alpha will be p plus 3 by 2, that means 5, and your beta will be p minus 3 by this, so 2. And for p equal to minus 7, your alpha will be minus 7 plus 3 by this, so you are getting minus 2, and your beta will be minus 7 minus 3, so minus 5. Okay, so therefore alpha equal to 5, beta equal to 2, or alpha equal to minus 2 and beta equal to minus 5. So you got these values. Done. Now what is our duty? Now we are supposed to form the quadratic equation which will have alpha plus beta whole square and alpha square into beta minus alpha into beta square as the roots. Okay, so let's do this. Now the quadratic equation with roots alpha plus beta whole square and alpha square beta minus alpha beta square is x square minus sum of the roots, that means alpha plus beta whole square plus alpha square beta minus alpha beta square x, then plus product of the roots, so alpha plus beta whole square into alpha square into beta minus alpha into beta square is equal to 0. Okay, so alpha plus beta, okay, alpha plus, okay, leave this right now. So alpha plus beta whole square, and here you can see from here we can take out alpha beta as common, so we get alpha minus beta, and here alpha plus beta whole square, and alpha beta comes out common, you are left with alpha minus beta is equal to 0. Now what we'll do, either we will put this or this, okay, and we'll get the answer. So x square minus, for alpha I'll put 5 and for beta 2. Alpha into beta will be 10 and alpha minus beta will be 3. Here alpha plus beta will be this into 10 into 3 is equal to 0. X square minus, here 5 plus 2 7, so you get 49, and here 30, and here 49 into 30 equal to 0. So x square minus 79x plus, and you can multiply this, so 3 9s are 27, 2 3 4s are 12, and 2 14, so you get 1470 is equal to 0. Okay, so this is the required quadratic equation which will have alpha plus beta whole square, alpha square beta minus alpha beta square as its root. Okay, so this question is solved and this will give you 6 marks. Okay. Okay children, so next topic that we'll discuss is common roots. Okay, so consider two different quadratic equations. Okay, like sometime it may happen that though you have two different quadratic equation, but you might get one common root. Okay, so we are just trying to understand what is the condition for two different quadratic equations to have one common root. Okay, so consider two different quadratic equations. Let's say first one is this: ax square plus bx plus c is equal to 0, where a is not equal to 0, and the other one is a dash x square plus b dash x plus c dash equal to 0, where a dash is not equal to 0. Sorry, it's not equal to 0. Okay, then these two quadratic equation will have a common root, means one common root. It will have one common root if this condition is satisfied. If a into b dash minus a dash into b, then here b c dash minus b dash c is equal to c a dash minus c dash a whole square. Okay, if this condition is satisfied, then we would say that there is one common root, okay, for these two quadratic equation. Now what is the formula to find that common root? Okay, so suppose that common root is denoted by alpha, then that common root will be given by this formula: alpha equal to bc dash minus b dash c upon c a dash minus c dash a, or you can use this. Either you use this, okay, or the second one. Okay, so this is the formula. So you will pause the video and you will write down this. Okay, for the common roots you will write down this, and now we will see a question. So let us see a question. Here we have one question. Okay, so here it's asking for which value of k will the equations this and this have one common root. Means what should be the value for k so that these two quadratic equation will have one common root. Okay, so let us see solution. Let x square minus kx minus 21 equal to 0 be equivalent to this: ax square plus bx plus c is equal to 0, and the second one, x square minus 3kx plus 35 is equal to 0 be equivalent to a dash x square plus b dash x plus c dash is equal to 0. Okay, so here your a is equal to 1, b is equal to minus k, and c is equal to minus 21. A dash is equal to 1, b dash is equal to minus 3k, and c dash is equal to 35. Now these two equations will have one common root when this condition is satisfied. When this condition is satisfied. If this is satisfied, then we'll say that these two will have a common root. Okay, So we will use this. We will substitute the values for a, b, c and a dash, b dash, c dash in this equation, okay, in that condition, and using that we can easily find the value for k, okay. So see over here, in order to have a common root, we must have ab dash minus a dash b into bc dash minus b dash c is equal to ca dash minus c dash a whole square. So now we will substitute the values, okay. So here we get a is 1 and here b dash is, okay, so we'll get minus 3k minus a dash is 1 and b is minus k, so this will become plus k, and here b is minus k and c dash is 35, so you get minus 35k, and b dash is minus 3k and c is minus 21, so you simply get 3 and here multiply, so you will get 63k. C is minus 21 and here, so you get minus 21 and minus c dash is 35, a is that, so we get this whole square, okay. Okay, now we will simplify it. So here minus 3k and here plus 1k, so we'll get minus 2k, and here minus 35k and here also here minus 63k, so we have to add, okay. So here we'll get into minus 98k, and here minus 21 and minus 35, okay. So we will get minus 56 whole square. So here minus into minus you get plus, so 2 into 98 and k into k square, and here minus 56 whole square, so you can simply write 56 into 56, and then k square will be equal to 56 into 56 divided by 2 into 98, okay. So 2 1 ja and here 28, and here you can do 2 49 ja, okay, again 7 7 ja and 7 4 ja, 7 1 ja and 7 4 ja, so you are getting k square is equal to 4 into 4, so k will be plus minus 4, okay. So the quadratic equations, okay, will have a common root for either 4, k equal to 4 or minus 4. So this is the answer, okay. Now let us see the next question. Here it says if x square plus px plus q equal to 0 and x square plus qx plus p equal to 0 have a common root, prove that either p is equal to q or 1 plus p plus q is equal to 0. So let us see solution. Given x square plus px plus q is equal to 0, and okay, let me put this as 1, and x square plus qx plus p is equal to 0. Let me put this as 2. So these quadratic equations are given, and they are saying that these two have one common root. Okay, let alpha be the common root. Okay, now since alpha is the common root, that means alpha will satisfy equation 1 also and equation 2 also. Okay, so let alpha be the common root, then from 1, okay, from 1 you will have this alpha square plus p alpha plus q is equal to 0, and from 2 you will have alpha square plus q alpha plus p is equal to 0. Okay, now what we will do is, let's say this is equation 3 and this is equation 4. Now we will subtract equation 3, or you can say, okay, subtract equation 3 from 4, or 4 from 3, best 4 from 3, subtract 4 from 3. So on subtracting, what we'll get, this will become minus, this will become minus, this will become minus. So we will get, here we'll get p alpha minus q alpha, and here you will get q minus p is equal to 0. Okay, so this implies p minus q plus, and here q minus p, instead of writing q minus p, we can write like this, minus p minus q. Okay, when you open the bracket again you will get the same thing. Now you can see that here p minus q and here p minus q, so p minus q common, and you getting alpha minus 1 equal to 0. Now either this is 0 or this is 0, so p minus q is 0 or alpha minus 1 is 0. So this implies p is equal to q or alpha is equal to 1. Okay, now what we'll do is, now put alpha equal to 1 in equation 1. Okay, so equation 1 is this one. Here alpha square plus p alpha plus q equal to 0. So we will get 1 square plus p into 1 plus q is equal to 0. So 1 plus p plus q is equal to 0. Okay, so we have been able to show that either p is equal to q or 1 plus p plus q is 0. Therefore p equal to q or 1 plus p plus q is equal to 0. Okay, so it's proved. Okay, now let us see the next topic. So the next one is sine of the quadratic function x square plus bx plus c, where x belongs to real number. So this is a quadratic expression. Okay, ax square plus bx plus c. Okay, this is a quadratic expression where x will be always from real number. Okay, x will be always real number. Now we will discuss about its sign, means will it be always positive or negative, or for few real numbers it will be positive and for few it's negative. Okay, so we will discuss about that when this quadratic function will be only positive or only negative no matter what real number you take. Okay, or we'll see where it can be positive and for what values it can be negative. So let us see this. So see the first one. If the discriminant, okay, if the discriminant b square minus 4ac is negative, let's say you have been given a quadratic expression and you find that d is coming less than 0, d is coming less than 0, then in that case the sign of that quadratic function will be same as the sign of a, means same as the sign of the coefficient of x square. Okay, we will see few questions. Okay, so you'll write down this, and then second one is, suppose discriminant comes 0, d is 0, so in that case also the sign of the quadratic function will be same as the sign of this a. Okay, and third one, if the discriminant is positive, means greater than 0, in that case that quadratic function, okay, will have two roots, real and unequal. Yes, real and unequal. So let's say those roots are alpha and beta, and let's say alpha is less than beta. Okay, then in that case let's say alpha is here and beta is here. Okay, and this is the real number line. Okay, so the quadratic function will be positive for all real numbers lying this side and for all real numbers lying this side. Okay, so in that case expression has same sign as alpha for all real, sorry once again, okay, let's say this is alpha, here beta. Okay, so for all real numbers this side and for all real numbers this side, the expression will have same sign as a. Okay, so this is clear. So you can pause the video and you can write down this. Now we will see questions, okay, based on these. So from exercise 12 to question number 3, here it says, if x is real, find the sign of the following. Okay, so this is quadratic function. You can see this is quadratic function. A is 2, b is minus 6 and c is 5. Okay, now we have to find its sign. What would be its sign? So in order to find its sign, firstly we will find its discriminant d. So discriminant means b square minus 4ac we have to find. So here you saw that a is 2, that is positive, b is minus 6, c is 5, and discriminant is coming minus 4, that is less than 0, negative. Yes, so what we have learnt over here? We have learnt that if discriminant comes less than 0, then sign of the quadratic function will be same as the sign of a. Okay, so here it's minus 4, that is less than 0. Okay, so sign of the quadratic function will be same as the sign of a. So sign of a is what? Positive. It's a positive number. Okay, so therefore this quadratic function is positive for all x. Okay, no matter what value of x you take, okay, this will always come a positive number. Okay, you may try that. Now let's see the second one. See this one. This is the quadratic function, okay, and this, after rewriting, I can get this, okay, rewriting it. So here you can see your A is minus 5, B is 20, C is minus 21, okay. Now we want to find its sign. What would be the sign for this one? So firstly we will find its discriminant, okay. So discriminant b square minus 4ac, substitute the values and you are getting how much? Minus 20, okay, which is less than 0, okay. So that means d is coming negative. So sine of this quadratic function will be same as sine of a. So sine of a is what? Minus, okay, negative. So therefore this quadratic function is negative for all real values. No matter what x you take, this will be always negative, okay. Now see this. This question is not from your book, okay. Here find the sine of 6x square minus 5x plus 1 for all real values of x. So here a is 6, b is minus 5, c is 1. We will find its discriminant. Discriminant is coming 1, that is greater than 0, okay. And once it's come greater than 0, okay, this is the third case. If discriminant comes greater than 0, then firstly you need to find its root, okay, alpha and beta, you have to find the roots. Then in that case sine of that quadratic function will be same as a, okay, for this for all those real values except real values lying between alpha and beta. So let us see. So here discriminant came greater than 0, that is positive. So the roots are real and unequal. So firstly we will find the roots, okay. So we got the roots 1 by 2 and 1 by 3, clear. So this is real number line, okay. So here let's say this is 1 by 2, let's say this is 1 by 3 and here 1 by 2, okay. 1 by 3 is less than 1 by 2. So this is, let's say, alpha and this is beta. Now sine for the quadratic function, okay, for all real values this side and for all real values this side will be same as the sine of a, okay. So here sine of a is what? Positive. Sine of a is positive, okay. So here this has the same sign as the coefficient of x square, means it will be positive, okay, for all real values except for those which lie in this. Means if you take any real number, okay, less than 1 by 3 or greater than 1 by 2, then you will see that this quadratic function will be positive, okay. So you have to pause the video, okay, and you have to copy this. Okay, so for today we will keep it till